Well, in our previous video, we looked at sign substitution, and it is from this video that we are going to look at the tan substitution, how to integrate the functions which involve tan. I need to first take you to the background of how we come up with this tan substitution. Tan substitution. How does it come about? You remember when we were looking at differentiation, we did a lot of work of which we differentiated. We said that ddx of tan inverse of x, we said that this is the same as 1/1 plus x squared without a root this time. Do we still remember? Let me set a reminder again. A reminder is that if we are differentiating tan inverse of x, we let maybe y be equal to tan inverse of x, so that tan y is equals to x. Now, when you differentiate both sides, when you differentiate a tan, you get sec squared y. But because you're differentiating with respect to x, it will be dy dx is equals to 1. But sec squared x, a sec square is the same as 1 plus tan square. So dy dx is equals to 1. So that our dy dx is equals to 1/1 plus tan squared y, but tan square, rather tan y is x, so tan squared y is x squared. So it is going to be 1/1 plus x squared. So now it implies that from that result, then if we can differentiate tan inverse to get y, then also if we can differentiate tan inverse of x and we get this, then it means that when we integrate this, we get this. And that is what we are going to specifically look at, right? So the fact that, let me say, since the derivative of tan inverse of x is 1/1 plus x squared, then it would mean that when we integrate 1/1 plus tan squared x dx, we shall always get, when we integrate 1/1 plus x squared, we shall always get tan inverse of x plus a constant of integration. And that is what we are going to specifically look. So this result simplifies all the integrals of the form integral of 1/s squared plus b squared x squared dx. So we are going to look at the details of this. So we are going to begin with a general integral, whereby I will say integrate So if we are to integrate that, well, as we saw with sign substitution, we shall need to first create a one here. So this is going to be the same as 1 over, we don't have a root this time, so a bit easier, 1 plus b squared x squared over a squared, then everything dx. So which is going to be equal to the integral of 1 over a squared plus into 1 plus bx over a, then squared everything dx. So now here we are going to let bx over a, this one which is under the square, to be equal to this time tan theta, meaning that the theta itself is going to be tan inverse of bx out of a. So when we differentiate both sides, we are going to get dx is equals to, when you differentiate here, we get sec squared theta d theta, but remember it was b over a, so we shall have a over b because there will be cross multiplication. Okay, so implying that our integral would become the integral of 1 over a squared into so the whole of this is 1 plus, this was tan theta, so when you square it becomes tan squared theta, then times dx. Dx is a over b sec squared theta d theta. Amazingly, this is 1 over a squared sec squared theta, because 1 plus tan squared is sec squared theta, then times a over b sec squared theta d theta. A will cancel with the a, sec squared theta will go, so we shall remain with 1 over ab integral of d theta, which is 1 over ab theta plus c, but theta is already known as tan inverse, so we shall have that as tan inverse of bx out of a plus a constant of integration. So that is how generally it is done. That is how generally it is done. And from this concept, we are going to look at the details of these things. So we are going to cover some work and we see how best we can look at these integrals. So let's look at the examples. Let's look at part A, integral of 1 over 9 plus 25 x squared dx. So when you look at this one here, it's no big deal. It's no big deal. So it is going to be integral of 1 over 9 out, 1 plus 25x squared over 9 dx, which is the same as 1 over 9 into 1 plus 5x over 3 everything squared, then integral dx. I just made sure that I perfect this as a square, then I generalize it as square at once. So when you enter square, still it goes back to this. Then it is the bracketing that you let to be tan theta. So let 5x over 3 be equaling to tan theta. So that theta itself is tan inverse of 5x out of 3. And when you differentiate, you'll have this side. When you differentiate, you're going to have you can first cross multiply. 5x is equals to 3 tan theta, so that 5 dx is equals to 3 sec squared theta d theta, so that your dx is equals to 3 over 5 sec squared theta d theta. So looking at this, you can easily plug in, so it becomes integral of 1 over 9 into 1 plus the whole of this is tan theta, so it will be tan squared theta, then times dx, which dx is 3 out of 5 sec squared theta d theta. Sec squared will go with this because 1 plus tan is sec, so it is going to be the integral of 1 over 9 times 3 out of 5 d theta. So this one can reduce. Okay, this one can reduce to 1 over 15, so it will be 1 over 15 because this is by 3, 1 by 3, 5, by 3, 3 times 5, that is 15, then integral of d theta, so which is the same as 1 over 15 theta plus c, but the theta is tan inverse, so it is 1 over 15 tan inverse of theta, which is 5x over 3 plus a constant of integration. So by this idea, I want every viewer to integrate for me 1 over 1 plus 16 x squared, to integrate also 1 over 9 plus x squared, to integrate also 1 over 5 plus 9x squared. Here we have to be technical because when you factorize, it is going to become 5 into 1 plus 9x squared over 5. So as you are taking out the root, as you're taking out the square, here it should be 9x, it will be 3x out of root 5, then squared, because you have to make sure that this 5 is also taken as a square. But if you just square, it will mean that this was 25, but you put it under your root first, then you square later. So I'm going to do maybe let me go through this. Let me go through that. 1 over 5 plus 9x squared dx. So this is the same as integral of 1 over 5, 1 plus 9x squared over 5 dx, which is the same as the integral 1 over 5 into 1 plus 3x over root 5, then everything squared dx. So here you can let now. That's why you let your 3x over root 5 to be equaling to tan theta. Okay. So by looking at that, there now, it moves because you'll have 3x is equals to root 5 tan theta, meaning when you differentiate, you have 3 dx is equals to root 5 sec squared theta d theta, so that your dx is root 5 over 3 sec squared theta d theta. But remember here, when you take the theta, theta is going to be tan inverse of 3x over root 5. right? So now you can plug in this. So it implies that you will have the integral of 1 over 5, then 1 plus the whole of this is going to be tan squared theta, because if 3x over root 5 is tan theta, then 3x over root 5 squared is going to be tan squared theta. Then dx is root 5 out of 3, all right, sec squared theta d theta. Sec squared will cancel with 1 plus tan squared, so we shall have it as this is supposed to be root 5, not root 3. So I'm going to have root 5 over 3. All right. Yeah. I'll have root 5 over 3 d theta. Root 5 over 15. Root 5 over 15. Then integral of d theta, which is root 5 over 15 theta plus c, but theta is well known here. So it is root 5 over 15 theta, which is tan inverse of 3x over root 5 plus a constant of integration. So I'm going to integrate one that involves completing a square, and then I leave the rest of the work for you. I'm going to leave the rest of the work for you. Well, let's integrate this. I have one of so if you have something like that, you have to first work on this so that you first complete a square. So 1 plus 2x plus x squared is going to be equal to, you can put out a 4. So it is going to be, anyway, this is the same as, let me say 1 plus 2x plus 4x squared, the same as, begin with the highest degree plus 2x plus 1. Here I was going to jump some step and realize that you can get confused. So we shall put out a 4 so that it becomes x squared plus, when we put out a 4 here, this one remains a half x, because when you multiply a 4, it becomes 2x again, then plus this one will remain a quarter. So that it becomes 4. Now we complete a square. It is x squared plus a half x plus a half coefficient of x. A half coefficient of x. A half coefficient of x is a half. We add a half coefficient of x, which is a half coefficient of x, that is a half, then square. So that is 1 over 16. All right. So first leave a gap and say, remember this 4 is multiplying into everything. So say x squared plus a half x plus, leave a gap. We shall fill that a gap. Then, of course, plus this a quarter plus this a quarter. So what you put here is the half coefficient of x, which is 6, a quarter which is a half. The coefficient of x is also a half, then square, that is a quarter square, which is 1/16. So 1/16, but we don't want to change the meaning of the statements here, so we shall subtract that 1/16 there. So we shall be left with 4 into this one here. This is x, this is an expansion of x plus a quarter square, and this one here, a quarter plus 1 minus 1/16, you get 3/4. Why? LCM is 16, so you'll have 16 divided by here, that is 4. 4 minus 1, that is 3. 3. Okay. So we shall get 3/4 here. Generally, the whole thing, actually, the whole thing. Sorry, it is 4. Oh, yeah. When you multiply 4. So this 4, I beg your pardon. I beg your pardon on this step. I beg your pardon. It is going to be 4 into x plus a quarter squared, then plus this one, what you get here will be 3/16. Okay, it will be 3/16. Of which, when you multiply it, that is when it will become 4 into x plus a quarter squared, then of course plus 3/4. I've multiplied a 4th out. So that is what we are having. So when we are integrating, now our integral is going to become integral of 1/, instead of this, we are going to write this. So it is going to be 4. I can begin with 3/4, then plus 4 into x plus a quarter. Then square dx. So accordingly, you are going to be, maybe someone else will teach you when he has found out by comparing with a general expression. One can compare with a general expression, and as well, one can also do it comparatively throughout. Okay, one can do it continuously, and then it also brings out the same answer. So this one here is going to be equal to the integral 1/, the mere fact that I need a 1 here. Okay. One may need to create a 1. So to create a 1, I'll factor out 3/4. When you factor out 3/4, you'll be left with 1 plus 4 x plus 1, x plus a quarter, sorry, squared. We divide by 3/4. So we divide by 3 out of 4, which will be the same as times 4 out of 3. So we have 4 out of 3 dx. You can take it slowly by slowly. So this is the same as the integral 1/3/4 into 1 plus, this is 16 over, shall have 16 over 3, then dx. So we may need to bring everything here. Okay, so I can say this is the same as the integral 1 over 3/4 of 1 plus 16 x plus root 3 the thing squared. Okay, then dx. So it is from this point that I can let x plus 1 over root 3 to be equaling to tan theta, so that my theta is tan inverse of x plus 1 over root 3. So doing that will get us x plus 1 is equals to root 3 tan theta. Let me simplify it from here so that x plus 1 will differentiate it, you will get dx. This side is going to be root 3 sec squared theta d theta. So I am going to move with these to the other step. I'm going to move with these ones to the next step. So in my next step, I'm going to have the integral of 1 over 3/4 into 1 plus 16. This one is going to be tan squared theta. All right. It's going to be 16 tan squared theta, then times dx, which dx has been root 3 sec squared theta d theta. We are going to look at how possible it is. I guess, I don't know if I have made an error somewhere. I don't know whether I've made an error somewhere. I guess I would have, from the previous steps, I would have carried that 16. I would have carried that 16 with a 4. I would have carried out that 16 with a 4. From a step where we have, from this step, let's check from this step where we have the integral of 1 over 3/4 of 1 plus 16 x plus 1 squared over 3 dx. Before we let, because this one is 1 over 3/4 of 1 plus this one, I can make it 4. All right, can make it 4, then x plus 1, then out of root 3, then everything here, everything squared. Let me use these brackets. So that even this 16 is catered for. Otherwise, it can give you hard time the other side. So that I say, let 4x plus 1 over root 3 to be equaling to tan theta. Now this is very, very interesting. It will come out very well. So this is 4x plus 4 is equals to root 3 tan theta. So that my 4, when you differentiate, you will get 4 dx this side is equals to root 3 sec squared theta d theta. So that my dx is equals to root 3 out of 4 sec squared theta d theta. And the theta itself here is going to be tan inverse of 4 over root 3 of x plus 1. So that when you substitute here, here, you're going to get the integral of 1 over 3/4 of 1 plus. Now the whole of this was tan theta. So here I have tan squared theta. All right, then times dx, which dx is root 3 over 4, then sec squared theta d theta. Sec squared theta will go with 1 plus tan squared. So you'll have integral of 1 over 3/4 times root 3 out of 4 d theta. Now here, I want you to be very technical. It is 1 over 3 out of 4. It's the same as 1 over, it is the same as 1 divided by 3 over 4, which is the same as 1 times 4 out of 3. So here we can say this is the integral of, I'm doing all these steps so that we don't get lost. So this is the same as 4 over 3 times 3 over 4 d theta. This one will go with this, so that you'll be remaining with root 3 out of 3 integral of d theta, which is the same as root 3 over 3 theta plus c. But theta is tan inverse of this. So my final answer is going to be root 3 out of 3 tan inverse of 4 over root 3 of x plus 1 plus a constant of integration. So that is what we are having. That is what we are having. So I want every viewer to do this question, which I'm uploading. And this question is, I want everyone to integrate from 0 to 1 of 1 over 3x squared plus 6x plus 4, and 0 up to a half of 1 over 3 plus 4x squared. Maybe for this, a hint on completing square, one can say 3x squared plus 6x plus 4. You can factor out 3, and then you'll be remaining with x squared plus 2x plus 4/3. Then you complete a square of this. You shall have 3 into x plus 1 squared plus 4/3 minus 1. I just want to see if everyone can come up with x plus 1 squared, then plus 1. Then you continue. So as you do these numbers, maybe you can comment on the comment, you can put your answers, and I will follow your answers up and see how best we are online together. Wish you the best. Till next time. We are going to integrate, we are going to move now to integration by parts in our next video. We shall look at integration by parts. Nice to be with you here. Good time.